Okay. Who remembers what 27 to the 2/3 means? What does that mean? Cube root of 27 squared. What's the cube root of 27? 3. Squared?
9.
So the answer to this problem is 9. No calculator. No calculator. Okay? I'm not giving you big, huge, ugly numbers, but you gotta be able to do that. What does this mean?
64.
The cube root of 64. Remember, the denominator is the root that you're taking. Cal, where have you been?
I just,
Did you do your homework?
yeah, I did.
Let me see it.
Is this word?
Yeah.
It's time for Lucy to go.
Bye, Lucy.
Bye, Lucy.
You have it?
I did the ones that I could try.
Say bye.
Okay. So remember, the point of reviewing is to do problems we don't know what they do.
Yeah.
All right. So the denominator gives me the root, the numerator gives me the power. So cube root of 27 squared. All right. How about this one? You're going to have your reference sheet. You saw that yesterday. So sine and cosine we don't change. So sine over 1. Sine over cosine.
Times 1 over sine.
And it would actually be 1 over sine squared.
Times sine squared.
Cosine squared over sine squared.
Times 1 over cosine.
And 1 over cosine. Yep. Now all that's on the reference sheet. Now what do? You start canceling. So those two will cancel with that one. That will cancel with one of those, right?
And then the other one.
Oh, and then there's another one over here. Perfect.
So 1.
So on the top we have 1, and on the bottom we have sine squared. And what is 1 over sine?
Cosecant.
Cosecant. So your answer is cosecant squared. Good. Okay. The next one I want to do for sure is, this is on the sheet. This is sheet number 2. 2a. Sine 240. No calculator. I mean, obviously if you had a calculator, you just type that in. This is a no calculator problem. So who remembers what we do to find the sine of 240? We draw. We always start here. We remember our labels. These are our labels. So won't 240 be right here? And then we take a perpendicular straight up. And then we figure out what this angle is. And it isn't a mystery. It's from 180 to 240. How many is that?
Oh, wait, you said
180 to 240. 60. And then you remember that across from the 60 is root 3. That jumps on your review sheet or on your reference sheet in case you forgot it. Right? What is the one tricky thing you got to remember? Negatives. Negatives. That's not on the reference sheet. You have to remember that in quadrant 3, won't both of these be negative?
yes.
And now we want the sine, which is opposite over hypotenuse, so negative root 3 over 2. Now, the exam question may not be sine, it might be tangent. And the angle might not be 240, it might be some other angle. But that's how you do that kind of problem. Draw your angle, make a triangle. Okay. Next one right on the sheet is 4a. Now I'm going to come back and answer your questions, okay? I just want to make sure you get these done. So 4a. How do we do this? This is an easy one. Loop-de-loop. So 5 to the negative second equals x. And what does 5 to the negative second mean? 1 over 5 squared. So the answer to the problem would be 1 over 25. purpose of all this is to jog your memory. Now you know what you need to practice and study. Okay, now let's look at for D and E. Now, D will be on the white part. No calculator. What is special about 9 and 27? They're both powers of 3. So I'm gonna write the 9 as 3 squared, and the 27 as 3 cubed. If this problem is on the no calculator part, then you have to be able to find a common base. It might not be 3, it might be 2 or 5 or something, but you make the bases the same. What do I do here? Multiply. So 3 to the 10x plus 2 equals 3 to the 6x minus 9. And now I can just set my exponents equal. So 10x plus 2 equals 6x minus 9. And then I just solve my equation like regular. Subtract 6x, subtract 2, and I end up with negative 11 fourths. Does problem D, the one we just did, look kind of like problem E? Yes. The difference is there a common base between 5 and 8? No. So this is going to be on the calculator part. The same kind of question, but it's going to be on the calculator part. And what are we going to do? We can't do that. So what are we going to do? Anyone remember? We're going to log both sides, yep. I think somebody said log it. We're absolutely going to log it. And when we log it, Charles, you wait. When we log it, we bring the x out in front. What?
Is it 3x on top?
Oh, it is. Thank you. So my 3x is going to come out in front. Now remember, you're solving for x. You want to get x equals. So what are you going to have to do? How are you going to get that x by itself? You're going to have to divide. And what are you going to divide by? 3 log 5. And then we go to our calculator. Log 8, close parentheses. Now be careful. How many things are we dividing by? 2? And this is like the ones we did before. Remember when we had like 8 factorial over 4 factorial, 3 factorial, something like that? How did we put that into our calculator? 8 factorial divided by, that's how you're gonna put this in. It's the same thing. So it's log 8 divided by 3 divided by log 5. Make sure you're closing the parentheses around your numbers. Log 5. Make sure you're getting 0.4307 as your answer. If you got that, you typed it in right. Next one I'm looking at is number 6. Again, I'm on review sheet 2, problem 6. How many degrees is 3 pi over 5? What do? I put in 180. Now you'll have a baby calculator, so you can do that math on the baby calculator. But the answer is going to be 108, 108 degrees. We put in 180 right there. Okay? Easy. Remember, there's only 20 questions, and some of them are like, all right. Now, 7. If you missed 7, there's 2 in no hope. What do we do with 7? We can eliminate or substitute whatever is your particular favorite. I, of course, am going to eliminate because I always eliminate, but you don't have to eliminate. If I multiply the top row by -4, I get -4x plus 12y equals -8. So 19y equals 19, and it looks like y equals 1. No matter how you do the problem, you're going to get y equals 1. And then what do? Plug it in. So I plug it back, you can plug it in any way you want. If I plug it in the top one, I have x minus 3 equals 2. So it looks like x equals 5. And I write my answer as an ordered pair, just like that. There's another one. That one and this one, you can't miss those. All right. Next, number 9. We're going to do A and B. Okay, nobody's going to have to do both, but there's different versions of the exam. So one version is going to have a problem like this, and it's going to say, find the area. Who remembers what we do? This is 9A. Who remembers what we do when we have that situation and we want the area? Add them up and divide by 2. Find half the perimeter. So the perimeter is, 34? So the semi-perimeter is 17. And we're going to use Hero's formula. So you start with 17. And then you take 17 minus each of those. So 17 minus 10, 17 minus 11, 17 minus 13. And then we multiply them all together and square root it. And I got 53.44. Some exam is going to have that question on it. Another version of the exam is going to have 9B on it. It's another area problem, but we're going to do it differently. Right? What's our formula or strategy? Not that you don't have to remember the formula, but what's your strategy? Area is 1/2 side times sine of included angle. 1/2 side sine. Let me just type it in. If you haven't used your calculator in a while, or if you've loaned it out, make sure it's in degrees. I got 71.62. I better make sure I'm in degrees, yeah. All right. I want to look at problem 12. It is another triangle problem. And I know what you're thinking. You're thinking 1/2, 17, 18 sine 42. But what is that? If I did that, what would I be finding? The area. Does this question want the area? No. This question wants side H. So, make a note, if you've forgotten, this is for area. If you want a side, or an angle for that matter, you want a piece of the triangle, you have to use the law of sines or the law of cosines. Okay, that's it. Those are your options. So area is great. Area is done like this. But over here, I don't want area. I want a piece of the triangle. So I'm going to do the law of sines or cosines. So look at the situation, which is going to be doable. That'd be cosines. Why does it have to be cosines? Because I don't have a pair. Remember that little deal? You gotta have a pair. Don't have it, can't use sines, must use cosine. So h squared equals 17 squared plus 18 squared minus 2 times 17 times 18 cosine 42. That is on your reference sheet if you recognize that. It's not labeled law cosines, but if you recognize it, that's on your sheet. And we can just type that in, just like it is. It equals, and then don't forget to square root it. You need h. So make sure you're getting 12.58. There's your answer. All right, now we're going to do 13, B and C. So we're going to do B minus 2C. So this one happens to be a subtraction. Addition works the same way. We just add instead of subtract. Be careful. If I keep it a subtraction, I'm going to multiply by 2. If you multiply it by negative 2, then it's not a subtraction anymore, it becomes an addition. It doesn't matter which way you do it, but you have to do it one or the other. So I'm just going to leave it a subtraction. I'm multiplying everything by 2, and now I'll subtract. So 5 minus negative 4 is 9. 6 minus 2, 0 minus negative 14, and negative 1 minus 6. And there's the answer to the question. Now, what about C? C is a multiplication. So do we remember how to multiply? So first of all, we gotta figure out if we can. And we can, remember that deal, those have to match. So we can multiply, and the answer will be another 2 by 2. So to fill all those boxes, we have to take these rows times these columns. So 5 and 6 times negative 2 and negative 7. And that's the number that's going to go right here because that's row 1, column 1. So what is that, negative 52?
Are you tired?
All right. And then row 5, 6 times this column, 1, 3. And that's going to be 23. Then we repeat using the bottom row. So 0, negative 1 times negative 2, negative 7. And 0, negative 1 times 1, 3. There we go. So we need to know how to add and subtract matrices. We need to know how to multiply them. Now let's look at number 14. Now, I think I talked about this yesterday. I hope I did anyway. That your problem don't have this in it. Okay? Because we never did that. All we talked about was amplitude and period. So, what is the amplitude of this curve? 3. What is the period of this curve? 360 divided by a half, which is 720 degrees. Or if you did it in radians, it'd be 4 pi. Either one's fine. Number 17, this is recent material. A 5-card hand is dealt from a standard deck. What's the probability you'll get no aces? Okay, 5-card hand. What's my denominator? 52C5. Okay, so again, show your work, because right there's half credit, right? You got the denominator right. Now, can we get the numerator right? No aces. What does that mean? All but 4. So how many are there to pick from if it's all but 4? 48, and I want 5 of those. Right, I shouldn't say half, because you'll get maybe a third for that, a third for that, and then a third for typing it in on the calculator. And you should get 0.6588. Or if you wrote it as a percentage, 65.88%. Doesn't matter to me how you write it. C, 18, number 18. How many ways can I select a committee of 4 from my class of 10? 10C4. If it said, how many ways can I choose a point guard, a center, I don't know, shooting guard, I don't know, what are some other positions? If I were picking 4 people for specific positions, it would be 10P4, but that one's 10C4. I don't know what that number is, but you can figure it out.
200.
Number 20, 3x plus y to the 5th. We don't want the whole thing, we want only the 4th term. I'm almost done. We want the 4th term. Where do we even begin? We begin with Pascal's triangle, and which row do I need to go to? The 5th, right there I am, there's my 5th row. Now, if I wanted the whole thing, I'd write down the whole row. I don't want the whole thing, I want only the 1, 2, 3, 4th term. So I'm gonna start with 10. That is the 4th number in the 10th row. I mean, the 4th number in the 5th row. All right? Now, what's gonna be next to that 10? A 3x and a y. what are gonna be the exponents? I'm not sure, I'm going to count. Right here in the first term, the exponent on my x would be 5. And here it would be 4, and 3, and 2. So I just count down. And if I put a 2 on that one, then that one's gonna be a 3. And now I simplify it. So I have 10 times 3 squared, so 90, x squared y cubed. There it is. There is your fourth term of that row. Number 22. Everybody's going on retreat. 48 kids are on retreat. They all like to pray or sing or both. 35 like to pray, 20 like to sing. How many like only praying? All right, so what's our dilemma here? How many kids voted for something? 55? How many kids are on retreat? What does that automatically mean? 7 of them voted twice. If the whole P-ball is 35, but 7 of them are in that spot, then there must be 28 in this spot. And if the whole S-ball is 20, then there must be 13 of them here. And then the question was, how many like only praying? 28. 24. Miriam did 3 homework problems on the first day. And then she did 7. And then she did 11, and so on. So what's happening here? Well, they're getting bigger, but we have an arithmetic sequence. Aren't we just adding 4? So the minute, you got your reference sheet, it has all these formulas on it. The minute you determine it's arithmetic, then you can narrow it down to these 2 formulas. How do I know, these are on my sheet, how do I know these are the arithmetic ones? They don't have R's. R means geometric. If you don't have an R, you're arithmetic. All right? What's the question? How many did she do on day 90? Which of these formulas is going to tell me the 90th number in that list? A sub 90. What does this one do? Something. So if the question said, how many did she do altogether? That would be that. But the question is day 90. So here's day 1, day 2, day 3, here's day 90. How do I find it? I take 3 plus 4 times 89. Using my formula. 359. She did 359 that day. All right, couple more. 26. 26. Limits. What is the limit of A? Huh? No, A. What's the limit of problem A?
Oh, 26.
26A. 5 halves. Oh my gosh, how do we find the limit? X squared over X squared, right? 5 halves. What about B? What's the limit there? No limit, because 5/3 is bigger than 1. Gotta remember our rules. 32. This is very recent. Find the center and radius. 32. find the center and radius. What do we have to do? Well, my x's are already together, but yeah, I need to get my x's together. And then I need to get my y's together, and then I need to complete the square. So, what's gonna go here? 16. What's gonna go here? 4. Okay, so I have x squared and y squared. What goes in here? X what?
12.
Plus 4. And y minus 2, good. And it's all gonna add up to 30.
32.
So your job was find the center and the radius. So what is the center? Negative 4, 2. And the radius is the square root of 30. Alright, one more. 25. I want you to look at that problem, and I want you to tell me the vertical asymptotes, the horizontal asymptote of the x-intercepts and the y-intercept. You will not have to graph one of these. Remember how we did those graphs, and you don't have to graph it, but you are gonna have to give me something. Probably not all 4, but I'm gonna pick a couple. Give me these 2, for example, or these 2, or some combination. So let's look at our problem. Does our problem factor? We probably should start with that. It factors. X minus 2 plus 1 and plus 1 plus 5. So it does factor. Not only that, but we can cancel. So now we have x minus 2 over x plus 5. Right? Okay, tell me what you know. Let's fill in these things now. Can you tell me what my vertical asymptote is? X equals negative 5. If you forgot, what note are you making to yourself? Vertical asymptote comes from the denominator. The horizontal asymptote is the limit. What's the limit of this? We just talked about that, 1. So y equals 1 is the horizontal asymptote. Where does the x-intercept come from? Numerator. So it's 2 comma 0, x equals 2, 2 comma 0, comes from the numerator. And then the y-intercept comes from plugging in 0. So that would be 0, negative 2. Alright, now, I didn't just do 20 problems, so I did not do every problem on the exam, but I did a good chunk of them for you, okay? So who found one? Naz, we'll start with you because you had a question. Which one did you have a question about, Naz? Which one? 4C. 4C. 4C is a calculator problem. You're going to need a calculator. So now we're going to go ahead and solve. So we're going to add the 6 to the other side and divide by 8. Oh, divide by 5. So now we have the equation that says the tangent of something is 8/5. And our job is to find the something. All right, anybody remember how to do this? It's a calculator problem. Inverse tangent, 8/5, that will give us the angle. So the second tangent, 8/5, and the angle is 57.99.
So my inverse is.
Yep, okay. Anytime you wanna find the angle, you're gonna inverse tan. Now, notice, this problem is a little bit trickier because there are actually two answers. We have 57.99, that's the one the calculator gave us. That's in quadrant 1. Why did I put another triangle down here in quadrant 3?
That's the
The
inverse.
tangent could also be positive down there, because couldn't, down here, won't these both be negative? And when I put opposite over adjacent, it's going to end up being positive. How big is this angle? That second answer, there's two answers. One came from the calculator. How big is the other one gonna be? 180 plus 57.99. Because you have to get all the way from here to here. So there's 180 and then another 57. That's a tough problem. Charlie?
Do we have to draw the graph out to get what's?
No,
You don't have to?
I'm not sure how you would do that without, but that's,
Oh,
No.
you need to do the graph to get the answer?
huh?
You need to draw out the graph to get the answer?
I think you have to, but I mean, I don't know how you're gonna do that. Did you get the right answer?
No, I didn't.
Okay, probably should do it my way then. All right, who else had a question? Sophia?
30.
30. Find the 27th term of this sequence. All right, now anytime it says find the 27th term, I know that I'm going to either be using this formula or this one. Those are the term formulas. The rest of them have S's, and that's sum. I'm not adding, I'm finding a term. So what do I need to really figure out here? Is it arithmetic or is it geometric? Now, I think you can tell, I hope, oh, what is that, 562? I think you can tell right away it's not arithmetic. Right? So then I'm thinking, okay, is it geometric? Well, take 750 and divide it by 1,000. So to get from here to here, it looks like I times by 0.75. Now what happens if I take 750 times 0.75? I get that. So this is indeed geometric, and the ratio is 0.75. So I'm gonna use this formula. I'm gonna find the 27th term, so A sub 27 will be 1,000 times 0.75 to the 26th. So it'll be really small. .5644. I'm not gonna give you a sequence that is not arithmetic or geometric. So the first thing you're gonna have to do is figure out which one it is. And then you'll have a formula and you can go from there. All right, who else had a question? What else do we got?
Can you do
27,
27?
1.23. Now, you're in luck, because this one is one of the easier ones, because other than the 1 out there in front, the decimal is, the whole thing is repeating. So 1.23 repeating. I'm gonna think of that as 1 plus .23, .0023, and so on. This part I can add. So let's just forget the 1 for a minute. I'm just gonna add that. Since the whole thing is repeating, we have a little trick. Does anybody remember what it is? That's gonna be 23 over 99. This is just gonna be 23 over 99. And then I have to add 1 to that. So actually, Lincoln, you could just write 1 and 23/99. Or you could get a common denominator and make an improper fraction, but that would be good enough. Remember, if there's no non-repeating stuff in there, 2 digits are over 99, 1 digit's over 9. Those are easier than the ones that have the other stuff. Who was that? Okay. Thought for a minute it was Mackenzie, and I was getting ready to come unglued. Okay, Nas? Quickly, Nas, we only have a couple more minutes. Which one you use? Five. Number 5. This one you need a formula for, but it's on your sheet. And the formula you're gonna use, looks like this. You don't have to memorize it, it's on your sheet. So it's this. So how much money will I have in my account if I start with this much? The interest rate, remember when you put in R, your interest rate, it has to be a decimal. Don't put 2.5. Oh wait, I'm out. I didn't read it carefully enough. It is compounded continuously, and that's this one. All right, so let's start over. A equals 1, 2, 3, 4. E to the 0.025. How many years am I leaving it in there for? 18. So now this is the compounded continuously formula, and it says I'm compounded continuously. So I have to use this one. And then I'm just going to type that in. Remember to get E, you press second ln. And you should come up with 1935. So $1,935.30. So these formulas are on your paper. This is the one for continuous. This is the other. All right, I will see you on some of you, I will see on Monday.